I finally got payments working in my app, but the hardest part wasn't the checkout, it was figuring out when a payment should actually be treated as completed. In this video, I'm implementing paid connects using Polar, including one-time purchases, subscriptions, webhooks, and the logic that ties all of that safely to my backend. I started by looking for a payment provider and landed on Polar. The onboarding was smooth, almost too smooth. The AI asked me to describe my product. I talked about Venting App in general, and it stopped me. It wanted to know exactly what I was selling. That's when I looked in the idea of connects. Once that was clear, Polar generated the products and showed how checkout sessions would work using their Python SDK. My first thought was simple: send a success URL, and when the user lands there, approve the payment. But that's not secure. Anyone could hit that URL manually. That's when it clicked. The success page is just a UI. The actual confirmation has to come from the backend. To do that properly, I needed webhooks. Polar doesn't support localhost, and they recommend ngrok. Ngrok requires setting up an account, so instead I used VS Code's port forwarding to expose my local server. That worked, but now I needed an endpoint that could actually receive and process these events, so I created a new Django app, transactions. This raised a bigger question: do I create a transaction when the user clicks buy, or only after the payment succeeds? Polar keeps track of checkout sessions, but Polar doesn't know anything about my internal users. That meant I had to create the link myself. I decided to create the transaction immediately in a pending state. That way, when the webhook fires later, I already know which user this payment belongs to. I wired up the Python SDK, stored the access token in environment variables, and created an endpoint that returns a checkout URL. While testing, I ran into a simple mistake. I was using my production token in the sandbox environment. Once the sandbox was fixed, I listened to every event. Checkout created, customer updated, order created, order updated. At first, it was noise until one event actually mattered: order paid. I ended up saving more data than I originally planned, not because I need it immediately, but because payment data has a habit of becoming important later. Refunds, disputes, analytics, audits, that context is hard to reconstruct if you don't save it. I also learned something important. Polar's customer object is not my user, so I use the checkout ID to reconnect the successful payment back to the pending transaction, the one that already contains the user context. When a webhook marks a transaction as approved, I don't grant connects inside the webhook endpoint itself. Instead, I use a signal. If the transaction previous value was not approved and the new value is approved, only then I add connects on the user profile. This guarantees the connects are granted exactly once, even if the event is retried. When I tested a $5 purchase, 5 connects showed up instantly. Once the user completed checkout and came back to the app, everything became unreliable. Sometimes the redirect would land before the backend finished processing the webhook. Other times it would land after, but the UI had no way of knowing that. View lifecycle hooks didn't reliably run after coming back from the checkout, so even though the backend state was already updated, the UI stayed exactly the same, and it only fixed itself after a manual refresh. I tried everything, nothing worked locally. Then I deployed the front end, and the problem disappeared. One last issue almost broke everything. The browser blocked the checkout pop-up. The fix: open the tab immediately, then update the URL. Subscriptions looked scary. Turns out they weren't. Every renewal triggers the same order paid event. No extra endpoints needed. That simplified everything.